And imagine I was hassling Sandy about the length of his title on Tuesday. Sorry about that, trying to squeeze the whole talk into the one sentence. I just wanted to correct or have your attention to the bottom line. As you see, the Institute of Marine Research has a logo that's been presented before. This time I'm here as a part of a steering group in Norway for what we call the traffic light system. This year it's managed or led by Erik Biring from Veterinary Institute in Oslo, and Tor Nesje is also from Nina in Trondheim. Myself and Tor has been in it since 2016, and so we know this system very from the inside. So I wanted to tell you a little bit about the processes that we have had in Norway and the very importance of science in it. The special thing about Norway in this context is that there is a political will for growth in aquaculture production. I put will in exclamation marks because I'm not quite sure what the correct English word would be, but there is a political drive for increased aquaculture production. The graph here in the blue shows the Norwegian production that sort of stagnated around 2011, 2012 because of environmental issues. The table at the bottom, I sort of pre-showed, it's included in the book outside, says something about the production of salmon in the world. And as you can see from the top line, with Norway being the larger producer, it hasn't really increased until the recent years. There's also a point that I made earlier today that, of course, like in Norway, where we produce about 1.2 million tons every year, the situation with the sea lice could be a little bit different. So what I wanted to tell you about, I'm probably the only speaker who includes a picture of myself, is just to prove that I did count sea lice at some stage, and I was very good at it. Then I had a laser operation, I'm not so good anymore. Anyway, the science documentation that is needed for a process like this, I wanted to tell you a little bit about the advisory process and the regulatory process. And the important thing for transparency is that these processes are kept apart. So in Norway, it started earlier than 2011, but there was a group appointed around 2009 that wrote what we call the area report. Roughly translated, they also call it desire for area. The Norwegian coast is very long, and to effective and sustainable use of this area in aquaculture was coming up as a very big issue. This report was headed by the then director of the Directorate of Fisheries. There was one person from the IMR in it as well. So it was a very broad group that wrote this report. They had 3 suggestions in this report. They said that we need to divide the coast into geographical areas. From before, the areas were managed by counting, which is not really biological correct in some instances. They also pointed out that if you wanted to have some regulations, you had to have indicators and rule of actions. And they also said that the industry had a direct responsibility for the overall solution to these common challenges. So this was the beginning of a sort. Here I have highlighted 3 things and put in a new word, because the geographical areas I'm going to address the indicators, but also the thresholds that was set and the rules of action that came afterwards. Better not rush through this. The Institute of Marine Research is an advisory institute, meaning that we have a free and independent role in all scientific areas, but the Ministry of Industry, Trade and Fisheries, these what they're called now, give us a mandate to say we expect you to answer questions in these areas. So they then asked us for scientific advice for indicators. They also did something that's a little bit more unusual. They said to us, what would you suggest as threshold values? Because threshold values is usually coupled to what a country is willing to take of a risk. Indicators, as this report show here, that came in 2012, a cooperation between IMR, the Veterinary Institute, and NINA in Trondheim. We're looking at effect indicators for sea lice and for escapees. These two things had been pointed out as the most important environmental effects in Norwegian aquaculture. But since the government wanted this to be growth, no growth, you had to have an indicator that actually had an implication when it comes to biomass. Escapees can happen everywhere. It doesn't really connect to biomass. You can lose a small farm, you can lose a big farm. So the end point was that sea lice or salmon louse for Norway was elected as an indicator. So this report is science-based, is scientifically revised, and some of it has, after the years, been published. And then we come to the thresholds that we will also address a little bit. So we did get a suggestion for thresholds. Susie Dolwyn showed you a table today about how these things were calculated, how many lice actually kill the fish, because this system is geared towards the environmental effects on wild salmonids from sea lice originating in aquaculture. So then the way was set, and we got another question. Ministry so then asked for scientific advice on production areas. And what is done here is that we have a coupled biophysical model that several of the talks have been, especially the first day, I didn't get to hear all of them since I was flying around Europe. And so this is used in this method here. The lice model here is lice from all existing fish farms, and the connectivity between them has been analyzed. This has been done by Bjørn Odlandsvik that Anders Sandvik showed a picture of the first day. We usually joke about that we put him on one plane and 3 or 4 of us others go on another plane, so we sort of divide the IQ equally between us in risk assessment times. And then he come up with this cluster analysis that you see here. They always like to twist the maps, these modelers, oceanographers, I don't know why that is. But he came up with this chart, or this map, that clustered into 15 areas. There is an example here on the left-hand side between what now is region production area 2 and 3. And you can see that within the area, the connectivity on PO2 on the lower side is fairly uncoupled from PO3. So this is the sort of basic principle. Within this map, also the deep red lines show farms that have a higher connectivity, and the yellow is when it's more dispersed or not so high connectivity. So then we were sort of coming around to having production areas because of practical issues. I don't know if you noticed. Is this the light? Yeah. For instance, there was a little fjord up here that sort of grouped very close together. And Finnmark in Norway is a fairly long coast. So they had some questions whether what would happen if they put it into a slightly different context, and they politically ended up with 13 production areas that you have seen maps of today. And here's another map. I think that with this process, it's very important to keep in mind that the science is very important. And that means that all of you contribute to this science that we use to sort of build stone on stone to have a solid understanding of how this is working. These things take time. I sort of started in 2011. As we see here, the regulation for the 13 production areas were stated in 2017 by the Ministry and the Directorate of Fisheries. So that's now a regulatory thing in Norway. What we also see with these areas that are taking physical oceanographical things into consideration is that more people are starting using them for other things, because the geographic boundaries for our counties isn't really fitted for this. So these areas are based on science and oceanography and can be used for more things. To get a little bit on with the science, this report came out in 2016. The two first names on the editor's list, Ørjan Karlsen and Bengt Finstad, are both here. So they are sort of responsible for some of this. As you also can see in the bottom here, there's a lot of logos from different institutes in Norway that contributed to this knowledge status in this system. This is to sort of try to have a very open process that we do describe the science, you put it together, you are a lot of people, scientific minds, working in this together, and you get a sort of consensus that this is the best we have, this is what we can use. So to add on to that process and the advisory process, it was proposed to the ministries that they could go for a process like the one in ICES. I don't know if you know ICES, it's the International Council for the Exploration of the Sea. We've been part of that for, I don't know, 100 years. They basically do a lot of fisheries. When you have shared stocks between countries, you send your delegates to ICES with all your data. In the scientific committee, they together find out what is going on and deliver a report to their advisory committee. So this is what we propose as a way forward in Norway as well. So basically you have all the data that you are going to use. And this data goes into the expert group of appointed scientists. There are a few of them here as well. Arne Sandvik and Bengt Finstad has been in it from the beginning and have stepped out. Ørjan Karlsen has been in it forever. I'm probably forgetting someone. Anyway, there's many good scientists in there. So this expert group sort of convenes just before summer, and after all the surveillance is done in the autumn, they come together and write a report and look at every production area, look at what the amount of sea lice is, and write a report, send it to the steering group, where I'm a member, and we give an advice to the ministry. And the reason I wanted to tell you a little bit about this, because it's not always thought so much about when you are into your science that you need to be very open and transparent when you're going into the advisory process and be very aware of the roles that each people have. I head up the research or the advisory committee in the IMR, and I find that very often I have to tell my scientists that no, they don't have to do that. You might think so, but it's actually a political decision what they'll do with the advice, because as you all know, you don't have to follow advice, sadly. So in this context, we have the appointed groups, the steering group and the expert group, but we also have tried to have stakeholder involvement, open working groups, where all the relevant researchers within Norway come together and update their scientific knowledge. I must say we're not always in agreement, so that can be very interesting. We also invite industry to be observers in these meetings, and so that they can see what happens. But there is also, when all this is said and done and the reports are finished, there's also dialogue meetings where the presenters of the results, there's a Q&A and a dialogue. There has been certain mentions of a trial and court case in Norway, so this hasn't worked as planned. I'll come into that. So the main elements of the traffic light system is the establishing of the production areas that was done on a scientific basis. Then you have the evaluation. Let me see, I can go like this. So you estimate the risk of salmon lice-related mortality in our population of wild salmonids. And it has been salmon for up to now. And I can't even spell salmon, I can see. The thing then is that we call less than 10% risk as a low impact. From 10 to 30 is a moderate impact. And over 30 is a high impact. The expert group only use low, moderate, high, and the political establishment actually puts the color on. Can be also very confusing. So then the ministry, government, decides what color they're going to put on these production areas to regulate biomass. They do it every second year. And if an area is put into red, they will have to decrease their production by 6%. Yellow is a freeze, and green, you get the growth. So, is it like this? I particularly like the one on the right. Because it's okay to be a little bit funny about this, but for the industry, it's very serious. So I've learned the hard way, making fun of this, having a little bit fun when I was wearing a red jacket, and they didn't find that funny at all. So now I bought a Faroese green jacket to be better prepared for next time. But anyway, so they decide the color, and this is the color for the period 2016 and 17. You've seen a list of the areas in another talk today, the 13 regions, and the results every 2 years. 2016 and 17, it was said beforehand, it's a trial run. We will give increased growth in the green zones, areas, but not do a reduction in the red. Then in 2018 and 19, the effect of all the colors should come in, and what is called production area 4 and 5 went into red, put by the ministry. They then sued the government and said that this is not correct, we are not prepared. I can't go into the whole court case. It's been a long process. They are now considering taking this into what you call the High Court or the top court. High Court, yeah. But in the areas that has been from 2016 to 2019, the green areas have increased their total allowable biomass by 45,000 tons. So on that part, it has worked. I think what is very important to sort of get into your head is that if the red doesn't count, then the green doesn't count either. I don't know if they had thought about that, but I think the green ones are just sitting and waiting for what will happen. So, where do we go from here? More science, obviously, and I'm very pleased at this conference to see so many young people. Like I said yesterday, I'm getting old. To see that we actually have more people coming in all the time. It would have been very sad if it was just few from the beginning years. So that's a good thing. As I said earlier, the traffic light system is meant to work for salmonids, sea trout and Arctic char, but we only have it for salmon as of now. So I've included here that sea trout and Arctic chars should be a part of the system. But we still, I don't know, I heard Bengt Finstad today. I think that we have to work more about the indicators and the possible thresholds.
You have just 1 minute?
Yes, I see. Thank you. This is my last slide. To have the scientific indicators that will be correct within the production area context, I think there's a little bit more work to be done. But there's also been an international evaluation committee in Norway who had 15 or 16 things that they said we could do, but simpler language was one of them. It was led by Crawford Reevy, so we read that very thoroughly. And obviously we have to work with a better dialogue. Scientists are not the best all the time to address issues and make it clear. So we are working with both the dialogue and the language needed for conveying what this means. But the end? Probably not. I might be back and tell you more about it next time. Thank you.